Now, so welcome to this question on 2025, question A2 on DCG a higher level. So why you should watch this video is for a comprehensive way of doing the eccentricity method for ellipses. So we've got the future office pod. It's based on the ellipse. We've got the axis A to A1, direction D to D1, one vertex, one focal point, points P and Q on the ellipse. So here's the solution with the eccentricity method. We have ordinates. Alright, we bring the ordinates up to the line of eccentricity parallel to the major axis to touch the lattice rectum or focal chord. Put our compass on F and we swing these back on to our line. Okay, our ordinates. Alright, so that's one AutoCAD solution. That's the state exams solution there. Alright, so we're going to get cracking on this. So it's good practice to start and find the vertex. The second vertex rather. So 45 degrees from F until it hits the line of eccentricity. Alright, and that works, this method works for all conic sections, whether it's the ellipse or the hyperbola. And the parabola with the eccentricity is going to have only one vertex with the second at infinity. So this method works for ellipse, parabola and hyperbola. Now, we have the vertex 2, alright, good thing is get the centre now. So we're going to put our compass on V, set our compass to any radius, we're going to swing an arc top or bottom from both sides, compass is set to more than half the length of the line. So we've bisected the line now, we can join them up. Now we've got our centre point. Alright, now, okay, we're going to draw in our lattice rectum. There we go, LR or FC, focal chord. Now the ordinates, it's good practice always to draw one between V and F. We're going to do one from P there because P is the point on the ellipse. And we're going to do one from Q, alright, because Q is a point on the ellipse. Now, we're going to bring those, okay, where they hit the line of eccentricity parallel to the major axis towards the lattice rectum. We're also going to include the centre as one, alright, so we're going to include the centre line as one here. So where the centre line hits the line of eccentricity, we can bring that over. Now, we're going to go with, alright, I'd say we'll go with one here in between, alright, F and P. So just we'll say we'll mark 10 there. They can be any distance apart, alright, and then we might go with 2 here, alright, in between V and Q. It can be any distance apart. Okay, so we'll go at 10 and 10 and 10 in from F. Right. Now we're going to draw the line parallel to the directrix to hit the line of eccentricity. So the two lines are parallel to the directrix to hit the line of eccentricity. Now then, where they hit the line of eccentricity, we're going parallel to the axis to touch the lattice rectum. Now we're going to label these. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, we're going to put our compass, okay, F. So we're going to put our compass at F. And actually, before I go on to do these, I'm going to label these going up as well. So 0 is the first one, the first horizontal line. Number 1 is actually at the line of eccentricity and lattice rectum intersection. Okay, so a point above the focal on the line of eccentricity is always a point. There's number 2, 3, 4, 5, 6, 7. Now we're going to put our compass on F. We're going to bring the nib to 0. Right, so we're going to swing that back, top and bottom on the line 0. And we're going to go to 1, I can put that at the bottom. 2, we're going to go up to 2 and swing it back onto the vertical line from 2, top and bottom. Now, we can go up to 3 now. And we're going to swing 3 onto that line there. We don't need to do it at the bottom because it's point P. Okay, we're going up to 4 here now. We're going to swing it there to touch the centre line. We don't need to do the bottom because it's going to be cut off by line P and Q. Because this is a hint here. Alright, that's a hint there. That flat bit. Now you can put it in if you want for the constructions, there's no problem. Now we're going up to 5, and we're going to swing 5 back onto the line there, ordinate from 5. Now we're going to go up to 6, and swing 6 back onto the line. Then up to 7. And then I must actually go back to 6 there. I want to do 6 and 7 below there. Okay, top and bottom. So 6 and 7, top and bottom. Now, the eccentricity method is hard to do accurately. Alright, now before I just do the before I go and freehand sketch the ellipse in, I'm just going to determine and indicate the second position of the focal point. Right, look, there, the distance between V and F, okay, here on the left is the exact same between V1 and F1 here, or A1 and F. Well, that's the axis A1, so V1 and F1 there. They're the exact same. So you have two choices. You can take the distance between V and F, move it over to here, or you can take half the major, swing from the top of the minor, which is when 4 reaches the center line there. So that's F2. Right, now I'm going to untape this sheet and freehand sketch it in. And there we have the question done. Alright, now the eccentricity is not an easy method to get accurately. Don't go too many points on the ellipse. That would be the key hint, right? If, say for argument's sake, you've done 10 ordinates, it's harder to have it look right then. Alright, 2 ordinates, okay, with 2 vertical lines would be way too much. So, alright, try to aim for around 6, 7, alright, would be okay. But the more you have, alright, the more difficult it gets to be accurate. Thank you, thanks for watching, so please like, share and subscribe.